Hi, my name is Effie, and today I'm here to talk to you about images, how to get started with images, how to add images to your Android project, and some of the best practices that you can apply to have a good user experience on your app with images. So I wanted to get started with the basics of what is an image and how it is stored, which is actually stored as a bitmap. So a bitmap is the basic structure that contains image data. And bitmaps are basically matrices where each dot in the matrix is called a pixel. And each pixel contains the color value of what to display. And together they form the picture that we see. And the bitmaps are characterized by two parameters, and that is the number of pixels that the image has and the information content, or what is the color depth of the pixel. And so, like I said, each pixel in the bitmap contains a certain information. Usually that is interpreted as color information. And that information content is always the same for all the pixels in a particular bitmap. To store a bitmap, we just actually use an array. And it has properties. The file has properties such as the height, the width of the image, and how many bits per pixel we're storing to store the color information. And the number of bits devoted to an individual pixel actually determine the number of colors that will be assigned to that pixel. So if we're using only black and white, we only need 1 bit. But if we're using RGB, then we will use 8 bits per color info. So that would mean 24 bits per pixel. So 8 bits for red, 8 bits for green, and 8 bits for blue. And if it's RGBA with the alpha, then it's 32 bits. Index color is sort of a shortcut to display bitmaps in a more storage efficient way. It means that I have a map. So if you think about as kids, we would have those coloring books that we would have like, wherever you see the number 1, paint red. So an index is just that. It's a separate storage that tells you, this is the color that I mean when I see this number. And then instead of, again, using 32 bits per pixel, we can use way less. Usually, we don't get bitmaps from the web or store bitmaps on our phones because they are very big. Again, 32 bits per pixel is really big, and it can get really huge, especially the larger the image gets. So what we would do is we would compress the images. And these are the 3 common image formats that you would see on Android. And image compression is sort of roughly divided into 2 categories. One of them is lossless, which means the image looks exactly like the original bitmap. And some of them are lossy, which means we lost some information while compressing the image, but sometimes the information is not perceivable to the human eye, so it's worth it. Out of these 3, both GIF and PNG are lossless. They will look exactly like the original image, but GIF images are stored at the most for 8 bits per pixel. So they are limited in the number of colors that they can contain. And a PNG is sort of the same advantages of GIF. It also has, both of them have the ability to have a transparent background, and it contains full color information and not just 8 bits per pixel. So out of the 2, PNG is more recommended by Google to use on Android. And JPEG is lossy, so we do lose some information when we compress the image to JPEG format. What it does is it creates a mathematical graph, a mathematical formula that approximates the real values of the bits and stores that instead of the actual bitmap. And like I said, some of the information is lost in the compression process, but often the loss is imperceivable to the human eye. And it works better when there are sort of smooth curves instead of sharp curves because it creates a graph. So like really sharp lines would look a little less good on JPEGs, and things like nature scenes or things that are sort of curvy will look better. Another term that we will hear a lot when talking about images is resolution. And resolution, quite simply, is the size of the screen or the size of an image in pixels. So if we say that the screen has 4K, it means that the screen has 4K pixels. How many, if an image has 32 pixels, again, 32 pixels, that's the size of the image. The other term we will use a lot is density, and density basically says, okay, I put 4K on the screen, but how big the screen really is. If the screen is really small and I put 4K pixels on it, then I will have a lot of pixels condensed into an inch. But if I have a huge TV and that TV is 4K, then I will have less pixels per inch on that TV. So density is how much we condensed the pixels on a physical screen. There is another format of images that you'll see a lot on Android and is supported on Android, and I wanted to discuss, which is the vector images. So if we go back to bitmaps that I was talking about before, they are, like I said, stored as tiny dots called pixel. Each pixel is a very small square that is assigned a color and arranged in a row to create the image. And so when you zoom in on a bitmap, you can actually see the individual pixels. If you zoom in enough, you'll actually see each and every pixel and their information. So unlike bitmaps, vector images are not based on pixel patterns. They are based on mathematical formulas to draw lines and curves that can be combined to create an image from geometric objects. And vector images are edited by manipulating those lines and curves that make up the image. So when a vector image is scaled up, the image is actually redrawn using the same mathematical formula. So the resulting image is just as smooth as the original. To create those files, those are basically XML files, and the extension that is mostly used for vector images is the SVG. And this is just, again, the XML file that contains the data, the mathematical formulas that are used to create the vector images. Android also supports vector images in a slightly different format. So often what we would do is we would get the vector image mostly as SVG file, and we would need to convert it to the Android format. And the way to do that is by adding the vector asset to our resource folder. This is a relatively new capability. It's since Android Studio 3.1 or so. And once we do that, we can import our SVG image, and it will translate it and create the Android vector image format from it. One thing to notice is sometimes you'll see a warning that some properties are being ignored because Android doesn't really know sometimes how to handle all the properties of the SVG, and that's fine. It will still create the vector image. It will just ignore these properties. And the other thing is that since it creates an XML, we can always go there back to the XML and edit the result if it's not exactly what we were hoping to get. I also wanted to go over a little bit about the classes and the basic drawing on Android. The first object that I wanted to discuss is the canvas. The canvas is the class that holds the draw calls. To draw something on Android, you basically need 4 basic components. You need a bitmap to hold the pixels, which is what we see in this image, the private bitmap and bitmap. You need a canvas to host the draw calls natively to the device. You need a drawing primitive, like what am I drawing? I'm drawing a rectangle, I'm drawing a path, I'm drawing a text, I'm drawing a bitmap. And you need a paint to describe the colors and styles for that particular drawing. So in the canvas class, you'll find methods that look like this. They are, for example, here, draw rectangle, and it has the size of the rectangle that I want to draw and the paint that I want to use. And it will call and draw rect, which is a native call that will draw the actual rectangle. The next concept that Android uses to draw things is something called a drawable. And drawable is a resource that is a general concept for a graphic that can be drawn on the screen, and you can retrieve with APIs such as getDrawable or apply to XML resource with attributes. And it is being extended by other, as you can see, it's an abstract class, it's extended by concrete classes, and they all override the draw method. And the draw method will tell the drawable how to draw itself, what to do, what shape to create, or what bitmap it contains, and it will send that to the canvas that it receives here in this draw method. Drawables can be applied in our XML in 2 ways. One of them is as a background to any views that we have in our app. And the other way is just in the foreground as an image view. And image views can do a bunch of other stuff that we will talk a little bit later. And like I said, there are concrete classes that derive from the drawable class. And some of them that I've mentioned or that I will discuss a little more are the bitmap drawable, which is basically a bitmap that we got from, that we added to our project. We have a stateless drawable that you can specify different bitmaps to display in case there's a different state on that drawable. It's basically a state machine, a gradient drawable, and we already discussed the vector drawable. So a bitmap drawable is relatively straightforward. Like I said, here's another example of how all the drawables override the draw methods and draw the thing, whatever they are drawing, to the canvas. And in this case, it's a bitmap. So it just takes the bitmap as is and draws it on the canvas. A stateless drawable is a way to provide different drawables for different states of a view. And a gradient drawable is a way to provide gradient color of, again, a view. And in the gradient drawable, again, this is just another example to show you that the draw method of the gradient drawable has calls for the canvas to actually draw things onto the canvas. So you can see here the canvas round rectangle or the canvas draw rectangle. They are all just calling the canvas with whatever they want to draw. Another thing that is drawn on the screen is a view. And a view is more than a drawable. A drawable can only respond to draw operations, while view respond to draw operations and user interactions like touch events and turning off the screen and more. And views can contain many drawables. So the class the class view also has the draw method, and in it, it also has a method called update display list if dirty. This is a little bit of a more complicated mechanism that goes through when you invalidate, when you refresh a screen, when you call draw on a screen. and it goes to all the children and draws all the views and the drawables on the screen. In this case, what I wanted to show you is that whenever this method is called, that means that a new canvas should be provided for that particular view. And that's the canvas that the view will continue to draw on. Another thing that happens in the draw method is the onDraw. And the onDraw is our way to extend the view and provide our own drawing. We want to customize the draw or draw something that we want to draw on this view. In this case, what we will do for a view is we would override the onDraw method, which is actually just a stub, and write whatever logic we want in there to draw whatever we want to be drawn on the view if it's not the default that was provided or we're creating a custom view, etc. In general, on Android, I sort of split the talk to talk about two things, and one of them is static images, which is images that we just want to add to our app and would permanently be there. So we want to add it to our package, we want to add it, and then the user will see them, the user will interact with them, we want to add them to our views. And the other side, which we'll talk about later, is dynamic images that are being fetched from the internet dynamically. So static images live in resource files. They live either as XMLs or as the original JPEG or PNG or any other format that we would want to use here. And if we're putting, if we're using MipMap, the MipMap folder, we're using it to put the app icons in there. And that is because we'll see this a little bit later, but drawables are actually being retrieved based on the screen's density. And in case of icons, sometimes some operating systems like to display bigger icons than the actual density of the screen, so they might break the rule, which is why we put them in the MipMap folder. So a good best practice is to put an image in the same image in different densities to correspond to the screen's density. And we do that because if an image is too small and we put it on a bigger density screen, we will see it pixelated. And if the image is too big and we put it on a low density screen, we will not see it pixelated, but we are just uploading to memory and displaying a really big image for no additional benefit. The user will not mind, they will not care that the image is actually bigger than what they can see. So we're just wasting resources. So in order to support different densities on Android, you must provide the image in different sizes. Otherwise, like I said, it will look blurry on higher densities or be big and take up unnecessary memory on lower densities. So first step usually is when we get an image from a designer is to figure out how big the designer provided this image for which density. And then we need to scale it either up or down into those different buckets. We don't necessarily need all of these buckets that are displayed on this list because Android will choose the closest approximation to the density that the screen has. But it is best practice, like I said, to provide more than one density. And so we would basically just scale either up or down from wherever we are. In general, the baseline is the MDPI, that's the 1x. And the HDPI is 1.5. The XHDPI is 2, and goes up from there. Once we do that and we have the image in different resolutions, we need to put them in different buckets so that Android will know where to look for them based on the density that it is looking for. So the way to do it is to create folders in the resource folder that will look like this and will have the different images in it, the same image, different densities in it. There is a plugin that I linked to here that helps you do that, so you don't have to manually create these folders. Once we do have the same image for different densities, and we put it in the different buckets, Android Studio knows how to display them grouped up. So it's kind of convenient to know, oh, this is actually the same image, only in different sizes. Now, image view also has other attributes that you can apply to it that make it useful to use an image view versus, like, I don't know, always put a drawable as a background to something else. And the two commonly used ones are applying tint on an image and scaling the image. And that's exactly what I'm saying here. Tint is very straightforward. I put an example here. The same drawable, apply the tint in the second view, and it changed the color of the image. Scale type, again, scaling the image to do a certain operation in case it's not exactly the size that I was expecting or the size that I want the image to be. And again, this is a link to a very, very useful blog post that shows this very clearly, what does different scaling means. Amanda Hill's post, so I go there often, so just go there whenever you have a question about what is fit start. So the second part that I wanted to mention was dynamic images. So this means, again, bringing an image from the web and displaying it on your device. So the very super basic way to do it, and you don't need to remember that at all, it's just to show you like the basic concept that is behind loading an image, is that if we get it from a URL, we basically get it as a stream. We just get a new URL, the URL of the image, we open the string. From the stream, we create a bitmap using a class called bitmap factory. And then we take this bitmap and we set it to an image view. That's the very super basic, how do I get an image from the web? The last topic I want to cover is good image experience. And that means, okay, now I have images, but how do I make the user enjoy using my app with images? And what is important to notice? So the first thing that is important to know is that images are big, and if we load them as a stream from URL and we do it blocking the main thread, then this is not going to be a good experience, and this is not going to like make the app enjoyable. So first thing we want to think about is how do we load images in the background? The second thing is caching, which is putting the image, saving it to the disk or to the memory. Again, if we're displaying the same image multiple times or displaying it in different pages, we don't need to fetch it from the web every time. It's just expensive and create copies of the same image in memory over and over again for no good reason. The third best practice is to put a placeholder there. Don't just change jump the size of the screen or surprise the user by popping an image once it loads into their screen. Put a placeholder, show the user that an image is coming, and create that space for the image. And the fourth one is resizing, which means, again, like in the static resources, if we're getting a too small of an image, then we will see an image pixelated. If we're getting a too big image, we wasted resources by storing in memory and uploading from the web an image, from the server, an image that is just too big and the user does not care about it. So resizing can be done two ways. It can either be done server side or it can be done client side. Server side just means that that we scaled our image to have different density, different resolutions, and then we just chose the closest one. We can do it from the server. If we have a list of different URLs, choose the one that is the closest to the screen's density and serve the right size. And the other one is client side. Client side means that we will get the image. Is it too big? We will not display it as too big. We will resize it on the client side and display the right size. And Android has actually a way to do that without opening the original bitmap and decoding it fully first, which is a good idea because if we are going to open and try to decode an image that is bigger than the phone's memory, it will crash on an out-of-memory exception. This is not a complete example of how to do it, and there was a talk earlier today that went more into depth about this and how you can actually just sample the image to see what size it is before actually opening the real image and resizing it again before actually opening the real image. It's more complex code that is more advanced, and you don't need to remember this or do this at all because it is a lot of work. It's really hard. And by now, if you're all thinking, now I have to deal with all of these and figure out how to do caching in my app and figure out how to do a placeholder in my app and figure out how to do all these complex resizing in my app, what do I do? The answer is you use a library. And imaging libraries are definitely worth your APK size, your method count, whatever arguments you can say about not adding third-party libraries to your application. Imaging libraries are really a must. They make all this experience so much smoother, and instead of reinventing the wheel and creating your own caching mechanisms and your own resizing and your own very complex algorithms, all three of these examples that I put here come out of the box with all these options. So Glide is sort of by Google, but not really. They don't officially support it, but they do endorse it. It supports fetching, decoding, displaying video stills, images, and animated GIFs. It uses an HTTP URL connection-based stack and also includes utility libraries. It plugs into Google's Volley project or Square's OKHTTP library. You can configure its cache to store images in the way you want it to store them. A second pretty similar third-party library is Picasso. It's pretty much the same gist. It's easy to crop, it's easy to resize, it's easy to handle errors, handling image view recycling and download cancellations if you're using an adapter. And the third one that is a little the oddball in this bunch is Fresco. Fresco is the oddball because it overrides the image view tree. So instead of loading an image into your regular image view, you will need to load the image into Fresco's custom simple droid view. On Android 4 and under, Fresco puts images in a special region of the Android memory, so it actually helps with memory and makes sure that you have less out-of-memory exceptions. It also makes sure that images are automatically released from memory when they're no longer shown on the screen. And it scales the image to a custom focus point instead of the center, if this is something that you're interested in. It can show the image with rounded corners or a circle. And another very important property of Fresco that actually does not exist in Picasso or Glide is image format called progressive JPEG. And progressive JPEG is a way to serve lower qualities of the same image and progressively switch to higher and higher qualities until you reach the maximum quality in case of bad network connection. So instead of waiting, I don't know, 5 seconds for the full image to load, the user will wait 1 second, see a low resolution image. After 2 seconds, they will see a slightly higher resolution, et cetera, until they reach the maximum resolution. This obviously has to be supported by the server. The server needs to know to serve these kind of images to the client, but Fresco is the only library that supports progressive JPEG. Now, this is how, for example, if we were using Glide, we would use it to load an image to an image view. And this is for this very simple example. You take the fragment or the activity or whatever you are using to load with, loading a URL of an image. In this case, I added the disk cache strategy just to show you that we can do that. We can tell it different strategies for caching. We can crop the image. In this case, I also added the placeholder. This is a placeholder that I'll be showing, and put it all into the image view. And that's it. Thank you.